guy, this section will demonstrate you the way to measure for the probabilities of the discrete probability distribution, including the binomial and the Poisson probability distribution. So first of all, we come with the first try of the binomial probability distribution. For example, we try with the 10 different trial for 10 times in total, and the probability of success would be P equal to 30% of 0.3. And the question would be measure the probability of being successful for like 4 times, for example. How can we do it this one? Actually, this is quite a simple, and the thing would be like you have to measure it by the function called binomial. And so all has been like integrated in Excel function, and you just have to call it out and dock this, okay, and dock this. All right, and this function will ask for the number of success. That's mean like 4 times, okay, right here. And the total number of trial will be 10 times trial overall. Probability of successful will be 30%, and cumulative or not, we will have to clarify later. So basically, this will be the function we're going to do with this one. Okay, and just remember that. And I try to generate for the answer of this one will be how we can do it. I will apply for the same binom dot this, okay, and then number of success with 4 times, okay. Alright, and the number of trial in total, actually this would be 10. Probability of success could be 30%, and cumulative or not. Cumulative true, that means you would just measure for the cumulative distribution function. Why? The false will be just for that moment of the math function only. That means over here we just want to measure for the probability of success for only like 4 times only. It's not like less or equal to 4 times. So here we just clarify it like 4, and then parentheses, and we're done. So that will be 20 or something. So basically, like I can easily just transform them into the percentage, and I can say it like they like 20.01% that we will be success. Exactly 4 times over 10 times a trial, okay. Alright, that will be the point. And the other thing would be like I can do the same methodology in the same fashion to just measure for the different kinds of. So I will call like x would be the number of success, like I say from 0, 1, and that means I can just spread from like 0 into maybe 10, okay, because we have 10 trial in total. Alright, and this will be the function of x, okay, function distribution function of x. And another thing would be like cumulative function of x, okay. Alright, and we will try to generate for the number and see like how they are different or not. Okay, so first of all, we the same. So basically, when we call the function of x, that means probability for success in how many times, like 0 times of successful. How we do it, the same thing, like binom dot this, okay, and number of trial of success in this time we will just base on this one, okay, the C7, and number of trial that should be 10, and we have to fix them, right, because at next time when we try to copy for the formula they will change, but number of trial will be always fixed, so we have to fix them with the $sign. The probability of successful is the same, 30%, and fix them. The cumulative or not, yeah, I would say like no, because I just want to see the exact number, okay, so I say 4, and para, that's gonna be what we want to do, okay, and the same thing, probability, okay, yeah, you can easily change it into percentage if you want, okay, and generate it like almost like it's 0% for 10 times exactly, but they are reaching into the highest function in like about 3. We're going to just generate it like to see this one, okay. Right, and how we're gonna do it, like I will try to generate for function actually a chart for demonstrating the um, statistical chart. Okay, I just maybe sometimes easily just generate by a function like this one, and you see the probability of successful for 0 from like 1 into 11 is a little bit different. Yeah, it's go wrong because it defaultly just think that it start from time 1, but actually it had to go from the time 0 into 10. Okay, so I change it a little bit, and I could go and select the data, and I change this one, go from 0 into 10. Okay, yeah, here we go. Here we go. You got it here. Okay, the same thing you can do it like as title. This could be the changing the number of success. Okay, number of success. All right, and this will be the probability. Okay, you can change it also called like the probability distribution. Okay, that could be the point. Also, you want to see the data label, you can put it on here. They're the same. Okay, the cumulative function actually they measure for, in the case like the question would be something like measure the probability of being successful for at least, like for at least. Okay, 4 times, at least 4 times. That means that it's equal to 4 or like 3 times or 2 times, 1 time or 0 time, at least 4 times. Oh no, I mean like at most. Okay, sorry, as most 4 times. So this will be the function how to measure for as most. As most will be from like equal or less than 4 times, like from 0 time to 4 times. We're going to generate for that. This could be the function to measure for this one, and that's the reason why we have to use for cumulative function. It's quite the same. I would just measure it right over here, and I would say there binom, okay, distribution, okay, and the function of trial that will be successful will be 4 times, okay, number of trial will be 10, and and another thing would be probability of successful would be 30%. The same 4, and I would say the time will be cumulative distribution function for true. Okay, and here we go. That should be 80%. So I can copy the function also. You can copy the function also, and because this is the cumulative function, so in the end all the thing will be summed up into 100%, and I generate into percentage and 1 2. Okay, this could be look very good now. So yeah, you can see it like this would be the way for us to measure for the cumulative function of successful ability. Now, in the same function, I can also apply for the Poisson probability of distribution. For example, in the one that we already talked about, like we had the lambda of 3, right? And the function of the like x will be 4, equal to what we already have it in the Poisson distribution. So over here we normally generate it with this function. It's quite I mean like it's not totally hard to just consume and do it all on just your kind of like, manual calculator. But of course when they already kind of generate it, right, generate with the lambda and so the x from the Poisson function, so they should be available somewhere on the Excel. And here now we're just doing the same. So all the thing you have to do would be just apply with the Poisson, okay, Poisson dot distribution, okay, and then x will be equal to right here. That's will be yeah, that would be the same, right? That would be there. um, we come back into, yeah, a little bit, like x will be equal to the function here, okay, mu, or lambda will be uh, power for x, so x will be 4, okay, so x will be 4, and the main function over here, this will be 3 times, okay, and the cumulative are not, for example, I just want to see they will be exactly the true, so probability of my function, okay, phone, and you got the same, you got, I get that it's quite the same with what you have to do. So this will be try to answer the probability of the number of the people come, so probability of 4 people, right? Yeah, I guess that should be the 4 people using the no, that should be 4 people, yeah, 4 people come in to the hotel, right? Hospital will be 16.80%. Okay, and yeah, that's gonna be in the same way you can do it with the high gonam with probability distribution. But I would be pretty sure that the binomial distribution, and you see also for the Poisson distribution, they are quite the same in the fraction of just measurement. And thank you so much for your attendance in this one. Appreciate.